Hey everybody, welcome back for week 14 of this training series with Bitovi. My name is Alexis. I'm a senior engineer for Bitovi. Justin will be joining us very shortly here. If you've been following for the past 13 weeks, you've seen a little bit about how JavaScript works in memory. You've seen how we put together basic widgets with jQuery. Now we're going to start to get a little bit higher abstraction with how we approach building web applications from a theory perspective. I see Justin's joining us just joined from Chicago, so he's going to be taking over this. But where would you like to start today, Justin? Oh, might be having a little microphone issue from Justin's machine. But the way we approach building applications at Bitovi, what we're about to get into a little bit is you may have seen a lot of MV star architectures, a lot of MV star approaches all over the web today, specifically with JavaScript frameworks. But it's really about where you maintain state in your application. With JavaScript, because it's such a dynamic environment, it's very easy to tightly couple things together. And a lot of the static languages or the more robust server-side languages like Java and C#, there really is kind of a way to do things to protect you from making things too tightly coupled yourself. With JavaScript, it's still a little bit of the Wild West, and you have a lot of freedom, which can give you great benefits or great detriment, depending on how you approach it in your application. So what I think I'm going to show you, actually do a little bit of live coding, is I'm going to take a very simple application. I'm going to build a very simple form. I'm going to be using CanJS, but this is a theory that you can apply across the board and talk about. You're going to see a little bit of live binding, but that's not really the focus I want to get into. It's really about how you maintain state in an application and what you should be concerned about when you're building an application. So let me flip a few things around here for you. Set up an IDE real quick, and then I'm going to share my screen with everybody. If you're just joining us for the first time and you would like to ask questions, we do have a Q&A section in the Hangout, or if you're joining us just on YouTube, you can check us out in Gitter. We are on the Bitovi/JS-training channel. Feel free to ask any questions there as well. So let me set up some screen sharing. Nice. I've entered the matrix there for a little bit. I'm going to use a couple tools you may have seen, you may have not seen, but even if you haven't seen the tools I'm about to use, I guarantee you've seen something like them. So I'm going to build a simple package JSON. This is for NPM. If you're not familiar with NPM, it's just how we manage dependencies for various things. If you're familiar with Maven, or there's a few other good package managers out there for different environments, but I'm going to use NPM. I'm going to do a few things here. I'm going to use Steel. If you're familiar with the term module loader, Steel is one of our module loaders that we use today because I like writing in ES6 and I like the workflow that it gives us. But if you're familiar with Require.js, Browserify, there's a few different tools out there today. And I'm going to use CanJS because I want to do something cool with separating state. And of course, I'm going to use jQuery. I'm a big fan. And I believe that's all I need. That's all I'm going to use for this little demo. Okay. Let's set up a simple hello world for us. Hey, I hear clicking. Is that Justin joining us?
Hey, Alexis.
Hey, how's it going, Justin?
Good.
Right on. So what I'm doing really quick is just setting up a little live coding demo. We're talking about, and you can feel free, we can change topics here, talking about how we approach maintaining state in an application. So what I was about to illustrate is just a simple form, and talking about the focus should, so often in UI developments, we get focused on, hey, I need to get the value from this input, I need to massage it, send it to the server, but we're always coupling logical concerns with presentation concerns, basically. One of the big parts of how we approach applications of Bitovi is separating those two concerns. A really groundbreaking concept, separation of concerns, I know, but still very important.
Yeah, so so this one is the web application theory one, right?
Yes.
So it's less about, well, it lends itself to separation of concerns and that kind of stuff, but it's more like on a high level what we care about and what we value as Bitovi, really, when we're building applications.
Sure.
So what I mean by that is, so Bitovi, Alexis and I are part of Bitovi, and we're a JavaScript consulting company. We've built a lot of really big applications for the last 8 years, and we can pat ourselves on the back a little bit and say that we're experts in this. By the way, we got Gitter going. Did you do the whole like Gitter introduction thing?
Tweets are out. Let everybody know the Gitter. We're good.
Cool. So if anybody has questions or comments, because this one is going to be a little bit more philosophical than all the other ones, because we kind of went through all this background training to learn JavaScript and stuff like that, and now we're kind of pivot and actually probably start building things. But before we start building things, I find it's always useful to talk about like what you value when you're building those things. Like, what do you value? Cost effectiveness, right, is something that people value. Or like time to like actually get a feature out the door, right? How do you trade? You can very well in an application development cycle trade today's features for tomorrow's. Meaning, if I want this done today, I can build it without tests sloppily, but then the feature I want tomorrow, it's never going to be, you're never going to get it. So what I think is valuable is discussing my and Alexis's values in regards to web application development before we actually start showing like how we do things and kind of convince you to do them that way. Well, it's all kind of based in what we value from our experience as developers.
That's true. That's true. Very true.
So I wanted to find, there's this article that I saw just last night that I retweeted from Bitovi's account, and I'm gonna give me 1 second to find it. It was this great. How do I see my retweets? Gosh, I gotta find this article. It was some Medium article where it was like it was kind of a joke. The person was saying, okay, I want to build a simple to-do application in Backbone, or not in Backbone, with just jQuery. And then someone's like, oh no, you can't use jQuery. You need to, you need to have observables and learn all like this jargon about observables. And then the person's like, well, okay, fine, but I want to and then you got to split up your application into modules. But no, what about just using jQuery? And it's this kind of humorous article where the person wants to start with something very simple, building a to-do application with jQuery, and then it devolves into this madness of different frameworks and technologies and tools and things like that. And I have to find this because I'm not doing the story. Hold on, is it possible to see retweets?
I'm sure it is.
Oh, here we go. Tweets. Someone else has been playing with my Twitter account. So let me find this real quick. I don't think I can find it. Gosh dang it. I wanted to come prepared with this, but I couldn't get it. Oh, such a great article. Anyways, so I will have to find that later and put it as supplemental because it's a good read and it has a lot. It's very well related to kind of what we're. It's a good satire on what we're actually going to present as. Hey, this is what you should do: is use all these tools and technologies. And it's a really good satire of it to give kind of another perspective, which I wanted to share. Anyways.
Oh, yep, Justin, I got it for you. Manuel linked it, but I'm going to drop his link.
Oh, awesome.
In the chat there. Thank you, Manuel, for finding that.
Perfect. It is the future. So, yeah, they'll be like, well, you got to use JSX. It's a virtual DOM. It's so cool. And then it's like, what is JSX? And then it's like all this jargon about JSX. And then like, oh no, Backbone's dead. You got to move on to the next thing. And then you got to use web components and custom elements. And it's really interesting because this is so close to what we're going to present as what you should do. And it just makes fun of it, and then at the end, the person's like, I'm just going back to jQuery. I think hopefully at the end of all of this training, you'll see why going back to jQuery, although possible, is not a good idea, because if you're building a large-scale JavaScript application, you're going to have to build the things into jQuery that these frameworks are providing you anyways. You're going to have to provide observables. You're going to have a good build system. You're going to want to have templates because it's really obnoxious to author everything, and it's really obnoxious to author all of your HTML in something in JavaScript. So I don't know. It's still worth a read. So I put together this image, which I called Madness, which I think outlines my feelings on like web app theory and what is important and why we get to all of this crazy tools and technology, how we get there from something like a simple to-do application. I guess we don't actually get there from a simple to-do application. We get there from big applications on the order of something like Gmail that are, 50,000 or 500 kilobytes minified in gzipped, right? 200 lines of, or 200 files, each one with like maybe 1,000 lines of code. How do we, from those applications, how do we get to all of this madness, if you will? And what I think it starts with is the tension. Well, what you want, like what it starts with is what you want from like kind of from the user's perspective and kind of from product's perspective. So whenever you're building a JavaScript application that's not for yourself or with other people, you tend to have your product people, and they, I think, more or less can be, hopefully are aligned with what users fundamentally want. And what users fundamentally want is a fast, meaning like high performance application that's error-free, that there's no bugs in it, and it has great user experience. You agree with that, Alexis?
I agree.
Right? I mean, that's all. So what I always say is, like, if you had the budget, though, for 10,000 monkeys programming for 10,000 years, you would could get a fast, error-free application with great user experience. Just because they would, it's like that whole thing, 10,000 monkeys for 10,000 years.
1,000 dolphins in 1,000 wading pools.
Yeah, you can eventually do with enough time and resources, you can get this stuff. But the problem is we have constraints. And those constraints, Eric can even blow up this image here so it fits nicer. Those constraints are, it's almost always the first and foremost one is time to delivery and budgets, right? Like whoever you're working for, they don't have all year or all decade or all century to wait around for you to produce this application. They need to get it done, and they always want to get it done quick. And then the other constraint, primary constraint, is budget, right? We can't just, we can't hire those 10,000 monkeys. We have 2 developers, and that's all we can get to get this product out the door because we're trying to start a new business or something like that. And then there's a bunch of other constraints that become important if these are constrained. I think the most important, becomes skill sets when you're building front-end applications. Very few people know how to build a big complex JavaScript application, what I would consider the right way. There's all this, hey, you don't need jQuery, just use the DOM, or you don't need a framework, just use jQuery. I think people who say that really don't know what they're doing in terms of building a big complex JavaScript application. I would really like to find someone who, I would like an experience of someone who's built a big complex JavaScript application, didn't use jQuery, or didn't use a framework, and didn't end up building themselves one. It just, I don't think that's possible. But I think a lot of people who lack the skill set will say, oh, you don't need these things because you can build a to-do application easily without jQuery, and that other stuff can just tend to muck it up. But they haven't built on the scale needed to build big applications, which I think is part of the problem. Is then all this other technology you have to learn, and just a lot of people haven't learned it. So skill sets is a big problem for building big applications. The next is communication, right? How do you, if I'm building a big application with a big development team, let's say there's 15 front-end developers, and I'm working on one part of it, and I'm changing its APIs or things like that. How do I communicate what I'm building to everybody else so that they can use it, or they can edit it and make changes to it without pulling their hair out? How can I increase their discovery time? Those kind of challenges. And then finally, this one is just people really don't know what they're until you've built something, you're never going to know what you should have done differently. I don't really have solutions for this part. I don't know if Alexis, you have ideas. I don't really touch that in here. It's just the only thing I can think of is training. Get in touch with people who have done what you're trying to do before you've done it, and pay them to teach you what to do. And trust their guidance, I think, is useful.
It's just experience. However you achieve that experience through, some kind of training or coursework, or just, trying things yourself. Experience is the great teacher.
Yeah, a lot of times you can, it's good to build things and then rebuild them, but that hurts time to delivery. So, we're a consulting company, so obviously I'm gonna say, hey, hiring a consulting company or a training company is gonna help you here, but I believe in it because it's why we go to school, it's why we get training. Someone can often teach you something much faster than you're gonna learn yourself. That's why coaches are so useful in almost every sport or profession. Although I've never hired a life coach. Maybe I should.
Tiger Woods, greatest golfer on the planet, arguably in history, has a coach.
His dad?
No, it's not his dad. He has a coach right now. Yeah. It's the point I'm trying to make. You always have someone to help you progress.
Yeah. Well, he could use a life coach too. So, okay, so now there's these constraints, and what you want is quality. Now, I think what gets you quality most directly is the ability to quickly improve and like, hey, I can quickly land features. I can quickly fix bugs, right? How do you keep, it's all about velocity, right? How do you keep your development team's velocity high so that new bug comes or new feature request, they can immediately make that change and land that, right? That's really, I think, the biggest driver for what end users really want. And what that quickly improve is really efficient development. That's what I'm talking about. Efficiency, for every dollar that you're spending on a developer, what return are you getting on that? Or every dollar of time, you're essentially, because money is time, what dollar of time are you spending on yourself? How you're spending your time to get these things. That's what you want, is efficient development, so that you can quickly improve and land these things. So to me, where all of this stuff comes together is really maintainability. There's a lot of things that you can do kind of outside the developer's purview, but maintainability is really at Bitovi, our focus on everything, right? Like that's all we really care about at first. We don't care about performance. We don't care about, we'll sacrifice features today for maintainability tomorrow, because we believe it leads to better product in the long run. So in terms of things like tech debt, we are really, really ability to our clients, and we hope that anybody who's building an application takes maintainability seriously, because it pays off in the long run. Applications take years to develop, right? Everybody thinks about the scale of the next release. We got to get it out this month. But all that really matters is long term. Be the tortoise, not the hare, that kind of thing. So Alexis, what does maintainability mean to you?
The simplest, if I had to break it down to really simple terms, it's ease of onboarding, I think, is a good test for maintainability. If you have really, really good documentation, that's the single biggest thing for me, is being able to get into a project, see the API documentation, it's up to date, and you're able to get into the code base very, very quickly, and you're able to make changes. Even if something goes wrong, that documentation is probably one of the biggest factors. Maybe one of the least attractive factors, but I think it's one of the biggest for me.
Yeah, documentation is a huge aspect of maintainability. But I think what you originally said is a really good indicator of maintainability. I call it the shoot the developer in the head test. I just made that up right now. If you were to take your best developer on a product and they quit the company, you took them out back, shot them in the head, how well would your application development cycle keep going? Would somebody else be able to take up that code base and keep your development cycles, would you be able to keep going? Or, as what happens way too often, is that knowledge in that person just it's totally in their head. They're the only one who knows it. There's no great way of extracting it or getting it from other people, or it hasn't been shared across the organization. What happens, right, if that person is gone? And if you are answering that question and it sounds a scary thing, then that's a big problem. So this is even a problem for us with our open source. For a long time, I was the dominant factor in all open source. I still am, but much, much less so over the last year. And now, in terms of CanJS and open source development at Bitovi, I don't do any open source development that isn't paired with somebody else, except for very minor things. I'll fix a test. I won't fix the actual code, but I'll write the test or just kind of do basic bookkeeping kind of changes by myself, but I won't do any major features or any like complex bugs on my own without somebody else, because that's just that's not a maintainable organizational structure to have one person know everything. So yeah, documentation is probably one of the biggest factors in maintainability. And for that, we use Document.js. There's a lot of different products. There's what's JSDoc is a very popular one. We use Document.js. And there's probably other ones on the market, but I don't know. So, but document, you can be a markdown file. It can just be inline documentation. But documentation is really helpful because not only in case somebody leaves, it helps bring other people up to speed. It helps communication. So if I'm trying to use someone else's API, I have a place to go look for that. And if I'm trying to modify someone's code, I know how I can be brought up to speed. And also, I think by people, when they write documentation, it's kind of like test-driven development. If you can write documentation for something that you're writing that someone is understandable for someone else, you've probably designed a good API. It's how we do a lot of our open source development. Right now, we're working on Done.js, and we really just started with the guide. Like a guide that covers everything. It's a huge guide, covers everything in Done.js, but we just started writing the guide, and before we wrote a lot of the code. And that's how you, I think, get a product or an APIs or code base that's, you know, people can use and understand.
Yeah. Hey, Justin, I'm going to interrupt you for 1 second. Could you turn off your HipChat notifications? It's cutting you off for a little bit.
Let me just close it. There we go. Okay. So I've listed 4 other kind of aspects of maintainability here. Testing. Of the 3, I actually don't know which one is. I think testing and modularity are probably the next 2 that I care the most about. Tests are absolutely vital to a JavaScript application. If you cannot at least have a smoke test and let you know if things are breaking, you're going to be wasting so much time going back and breaking other people's code, breaking things. You can't imagine how much time, like if I run CanJS's test suite, because I'm going to use CanJS just as like kind of an example, because any big application right now that I've written, unfortunately, I can't share. Oh wait, I wouldn't be doing it here.
You could just show them the link to Travis.
Oh, I was just gonna run it. So I can just run CanJS test suite. This is just the jQuery side of the test suite, and I don't know how many tests there are. We'll find out when it's done running. I can't tell you how many times, because of having a really comprehensive test suite for CanJS, I've broken something that I have no idea. Like I'm working on some code in one module, and it breaks some other code somewhere else. And I would have absolutely no instinct that it would do that. But because we have this darn well comprehensive test suite, okay, so it doesn't say how many tests. I guess it'll say if I scroll to the bottom. So there's 1,600 tests and 4,000 assertions. This has saved me so many times from creating bugs. But then the great thing is, here's the real reason why tests save time, is because I'll make a change that I might have broken something. Now you might think like, oh, well, you'd find it anyways and fix it then. So yeah, the test might have alerted you sooner, but you're still being alerted. You're having to run the test, and then you're having to fix it anyway. So how is you really saving time? you can't undervalue the context switching that how bad context switching is for most programmers, especially at least for me. If I find a bug while I'm working on the area, like I'm working on this area already, and it created another bug, it's so easy for me because I'm fully loaded with whatever problem I'm working on to fix other related bugs that it caused. If I have to pick this up even an hour later, all that information, because I've started working on something else, all that information is gone. So testing, it's like this, I don't know how to say this, but like this efficient development, a good maintainable setup for your application is essentially chipping away. Oh, I'm getting 5% more efficient. I'm getting 3% more efficient because I have tests. I'm getting 8% more efficient because everything is documented. Those things add up. And if you're talking about over the course of a year, 5% faster development, or let's say 10% if you added all these things up. Let's just say only adding these things up added 10% over the course of the year. Well, there's 52 weeks in a year. That's 5 weeks in a year. You've saved 5 weeks of time. A whole month you could just not be working because you've got a good maintainable system. Just people, I don't think, realize this stuff all adds up. So modularity, and we'll kind of get into that. Modularity is how you break up an application. So kind of every single responsibility principle. So every thing does just one thing on its own. That's again, just as important as kind of these other 3 tent poles that really hold up maintainability. Every piece of code that you build, as much as it can, have it try to do one thing and then assemble all of those things together up until your big application. That can be very hard to do right. There's some stuff that helps with it that we'll go through in a second. Actually, we'll go through that in 1 second because I do want to go through it now, but I just want to say what deterministic is. Deterministic really means that like everybody is pretty much building things in kind of a similar, repeatable fashion. If I am looking for something that loads data on the client in a CanJS application, I know where to go find that. That a lot has to do with documentation, and that helps with communication bottlenecks. If everybody's kind of building things in a similar way, that helps make things more maintainable. So you can kind of like, once you get the pattern, you know how everything else works and fits together. But back to modularity. So modularity is kind of splitting up things so that everything does just one job. And the biggest thing that we believe in terms of modularity is the thin server architecture, or the kind of the biggest influencer of modularity. The thing that has the biggest impact on how we program is thin server architecture. And what thin server architecture means is we do pretty much everything on the client that the client can reasonably do. We believe in servers should be doing business logic and data, and the client should be building all, or at least some client. It's a little bit different now with isomorphic JavaScript, but essentially a client should be building all HTML for your application and dealing with the user experience, all the UX. So what that does is that makes things, at least puts a hard dividing line in your application, right? It splits your application in two. On one side, you have your server doing, business or data and permissions and things like that, and providing nice RESTful APIs. And on the other side, you have your client doing UX stuff, but there's a dividing line. Okay, I need to, do a drop down and that kind of thing with a bunch of options that the user can see. Well, the server should just be able to provide a list of potential options, but the client is what should build the actual drop down and the LIs and things like that. You've done this single responsibility principle. You've at least split your application up once, which I think really helps building big complex web applications. Any thoughts about that, Alexis? Yeah.
It's huge. I mean, this is still a big heated debate if you're talking about client versus server rendering. I mean, the right way really is like a mixture of both, maybe the initial page from the server and subsequent loads from the client. But this is, if anybody watching is a gamer, I know Justin is, this is the reason you have to buy new Xboxes and new PlayStations. Video game industry has been doing this for a long time. If you want that responsive, rich environment, then you're going to put as much as you can, reasonably can, on the client. This is why you have like the 4 gig, Xbox game installs, is because they're putting as much information as they can as close to the user as possible, and then just basically maintaining state, some small messages going across the wire. In the late 90s, the early 2000s, the bottleneck was processing power. Computers were really, really weak. I remember somehow convincing my family to spend a small fortune on a RAM upgrade of like 4 megabytes in like 1999, which was insane. And today our phones are incredibly powerful. The bottleneck today is not processing power, it's bandwidth. So if you want that rich experience, you can have all kinds of visual state changes. If you're clicking a tab, you show a panel. The server doesn't necessarily need to be notified or any request being made of that kind of context change. But if you're doing any kind of persisting data or security, that kind of stuff should be maintained on the server. So there's a little analogy for you guys.
Well, let me kind of break down something that you said. First, I don't know if I'm a gamer. I play games, but I only play like 3 or 4 a year. And now that I've
Huh? That's my definition of gamer. I feel like it's an all-encompassing, all-welcoming. If you play games.
And now I've got a child, so I don't know. I feel like I've got to grow up now. Put childish things aside and become the man I can be. Okay, so you're absolutely right. Thin server architecture is a controversial subject, but I would say that thin server architecture on its own actually makes applications, like, unless you're doing a lot of work, it can make applications less performant, especially depending on the application. Now, there are ways to balance that out, and there's a lot of good ways of balancing that out, but like isomorphic JavaScript and virtual DOMs on the server and things like that. But this gets back to kind of what we value again, why we pick thin server architecture. So I believe that, yes, we want a fast application. That's absolutely important. But in the long run, maintainability gives us a fast application. And because I believe a thin server architecture is inherently more maintainable than a mixed, like a client where, like, the back end is doing a lot of building a lot of its HTML and stuff like that, because I believe that this is more maintainable, I think in the long run you will produce a faster user experience for the user with a thin server architecture. Because I think it's all about velocity. So let's say that thin server architecture adds that 5% or something, or even less than that. Well, let's just say 5%. Well, that's like 2.5 weeks where you can take that time to get thin server architecture equally as fast as a server rendered application, and then perhaps even make it faster. You can start doing good things with mem caching. You can add the performance things because you've saved time by essentially splitting your responsibilities of your application in two. And then thin server architecture also has another benefit, and I think that's with skill sets. There's a lot of companies that want every single developer to be full stack. Like I should be able to write a good SQL query and know how to communicate with Redis and know all, and then be able to write a great drag drop widget on the page. No, that person does not exist. I mean, maybe they do. That's one person, and they would immediately be bumped up to an architecture type of role, and they would never program ever again if they're that good at all of those things. So I find this like agile, hey, everybody's got to be good at everything thought is, I think, doesn't actually work in practice and is kind of ridiculous. Thin server architecture, because it says, hey, backend people, all you got to care about is making RESTful interfaces that run really fast and don't break. You go do what server teams should be doing best. And hey, front-end people, you don't have to worry about any back-end code. You just make the slickest widgets that perform really well in mobile and work great. That splits up skill sets, so it makes it there's less things people have to do, and it can help communication, I think, because essentially you're communicating on the service layer. A lot of our projects, and I think I wrote this in the blog article, gave an example. I do want to show this. Services. Okay. We like to do a good job. Oh, nope, that wasn't it. Oh, we document services like this. So we, when we're working on a client project, hold on one second, Alexis. We document, we have this nice form of documentation, and this is pretty much how we communicate back and forth between client and server teams. All right, so for every kind of back-end service, we say how to create it, the different parameters, an example of what people are sending back and forth, and we document that for every kind of URL based on the kind of the RESTful noun. Although this should not be called services, this should be tasks. So I think thin server architecture can also help communication that way, because it essentially forces you to provide this API for your server, which is very easily consumable for clients. Okay, so the other thing, I guess I have some of these other things here. Yeah, so we have the REST standard services. I just talked about that. So multiple clients, thin server architecture can help with a lot. Hey, you want a mobile version, a mobile web version, I don't know, an iWatch version, who knows, a desktop client, all these different clients. You want other people might want to consume your APIs. Well, if you're creating if you're using thin server architecture, you've had to produce nice RESTful APIs. So you are already more set up to handle multiple clients. So then finally, okay, once we decided on thin server architecture, okay, now you need to build everything. So when it finally comes to that, we think CSS can be hard to maintain. Less and Sass can make that easier. For the DOM manipulation, we have jQuery, and for things that jQuery doesn't do, we have jQuery++. For our client, we're using CanJS, and we'll be using that for all the future training material. And for dependency so this is MV star. So I think we can get into this, like, is jQuery just enough? We can get into this argument. We kind of already talked about can you use the DOM and not jQuery? No, don't be crazy. I don't know. I don't get people who say that. And can you not use a framework? Yes, if you're writing something really simple, you can. Like, I mean, to do MVC, I would still use CanJS because I'm so familiar with to do MVC application, but I could very well write that in jQuery. But I would say some things, when you have true observables, so let's look at to do MVC here. Is it .com or org? So let's look at the CanJS version here. Okay, so things like this, where I change the state here and this items left changes, and if there are no completed, clear completed removes, that kind of functionality is a million times easier to do with any JavaScript framework than if you're going jQuery alone. So again, when people are like, hey, you don't really need a framework, I always wonder, what are they doing to handle these cross-cutting concerns? So, I mean, they just write a click handler, and they probably go to this code and change it, and then go to this they probably add up the number of completed items, then have to go to find this div element, update it, and then go find this and update it too. But that means this click handler is not only dealing with this one task or to do, it's dealing with all of this other stuff. And that doesn't scale, right? Yeah, you can make it work in, you can make it work, but it just really doesn't scale. Actually, now's a great time. Do we have that? Alexis, I don't know if you got handy that, you know, the Google analytics.
For?
You know, it shows the observable, how important observables are. The PowerPoint. You know, we show the. I don't know if you get that. I'll bring it up if you have it. Where is that in? Do you know?
I don't actually.
Okay, I think it's in. I think there's one in a. I think here, I'll explain this really good here. Where is the PowerPoint? Okay. Just to kind of cover the importance of observables. Here we go. Can you see my screen, Alexis?
Sure can. There we go.
Okay, awesome. Okay, so here's a very basic app that is about the same complexity to do MVC, where you can pick what kind of social places you want to search for a term, and then it saves that term you searched for in the search history, and it shows you the results for that search. And if I were to click back on my search history, it would then kind of update this with what you search, and also update the search results. So the naive way that people write this is kind of what I was just talking about to do MVC, where they have 3 different widgets. Sure, you're breaking it up in 3 different widgets, great. But it listens to when this form is submitted, and they would call out to the search history to add search data, and they would call out search results to update it when someone submitted this form, right? So they get the data from the form and say, hey, history, add this. Hey, search results, update this. If you're doing this kind of thing, this is wrong. We'll see why. So that creates a dependency on this widget of these 2 widgets. Now, if you do something similar in the search history, when one of these is clicked, you're going to update the search form with what was clicked, and you're going to update the search results with what was clicked over here. Well, now that depends on the search form and search results, right? So this isn't so bad. Again, it wouldn't be so bad in to do MVC application. It's not so bad here, but if you're writing something big and complex, it absolutely breaks down. So let's take a look at, this is Google Finance's, you know, I don't know, chart for a stock. So let's look at all the different widgets here. There's one here, there's one there. So this is like, you can select the range, another way to select the range, another thing showing the % change in the range. There's the graph itself. There's like a subgraph that shows like what part of the, like, you know, almost historical time you're actually seeing. There's a little scroll thing, and then there's the big scroll where you scroll through like a huge, bigger timeline. Okay, that's a lot of stuff. Now, if if I were to write that same, the previous way that we were just writing code, when I listened for click on this, I would have to update every single other widget in this page, right? All of these would have to change. And then same with, if I were to change this little scroll area, I would have to update all the other widgets. And this, every widget would have to update, have code to update every other widget. And this is the handshake problem, where every person needs to handshake another person in the room. This is a n squared problem. And while n squared isn't bad for computers to handle, right? It can, you know, if you've got 100 items and it takes 10,000 iterations for a computer to work out that problem, that's not bad. But it's very bad for people, extremely bad for people. So what frameworks do, all of them for the most part, they let you change this into this, where you have observables. So now jQuery can have some form of observables. You can trick jQuery into having observables for you because its event system can be added to normal objects. That's great, and that's a big start, but nobody knows how to do it, and nobody uses, I've never seen a person actually using, other than like us sometimes, using jQuery in that way. When people say frameworks, I think you need an observable system. If you don't have that, you're just kind of shooting yourself. So that's the MV star part of this. Now, the final thing is dependency management. So this has a lot to do with modularity. If everything has its own, every file is doing just what it should be doing, part of that it should be doing is saying what else it actually depends on and needs to work. I'm a big fan of having something like common.js or require.js, Unit or Browserify, that kind of stuff. You need some form of dependency management where every script is declaring its dependencies, pulling those things in. We use Steel.js for that. That's what we built. It's really good at making high performance builds, and it supports all different, it's kind of like Webpack, but better. Because its build system is better, I think, and it's based off of, I think, its core is based off ES6 module loader spec, so its plugins should hopefully be future-proof. Anyways, we use that for dependency management. So this kind of fills out why we think all of these things are really important for getting maintainability and eventually a fast, error-free application with good user experience. So that's my spiel.
It's a good spiel.
Yeah. Anything you want to add, Alexis?
No, this is a really, I love this graph. I forgot we had this. This is a really good overview of the ideal approach, our opinion, of course, of the ideal approach into building a large application. And that's really, there was a wave of you don't need an MV framework, you just need jQuery. But it's weird right now. There seems to be like a resurgence of a wave where you don't need jQuery. But it's the same argument. Technically you don't. Technically, we don't need the internet either. But
you build your own browser. And
yeah, you're basically, you got to make your bed somewhere, and there's really useful abstractions in, you know, every one of these libraries. If you're using jQuery or Dojo or some DOM abstraction and tool set for working within a browser, and then if you're building some kind of architecture for, if you're building, you know, Gmail, you're going to want some kind of abstraction. It's one of the MV frameworks typically. So there's a reason all of these exist. So if you come across that in your own experience, take that a grain of salt. Take what we're saying with a grain of salt. Go out and educate yourself on why this is, why we consider this a good approach. You know, maybe you've looked back in something you built in the past, maybe in a different language, because this, you'll notice there's tool sets in the purple areas, but this is really just how you build an application. The theory, I think, is applicable. Obviously, the thin server architecture is very specific to web applications, but this is really applicable to just software engineering in general. So I agree completely.
Yeah. Yeah, so what we'll be doing for the next kind of, this is in some ways the dividing point. This is the next lecture of our training series here. We'll be building with these tools in mind and maintainability, what we consider maintainability at the heart of everything. Cool.
I concur.
All right, and if let me actually just share my screen one more time real quick. That blog article that kind of walks through this is Bitovi, blog bitovi.com, web application theory. We'll make sure we link to it in the article that we produce. So you can kind of, I basically break it down the same way, and there's more links to supplemental information. Although we could update it to say that the search problem is really gone now that we have server-side rendering.
I think we just got a little DC there from Justin, but yeah, the article could be updated with a few things. Server-side rendering is something new that we've kind of adopted at CanJS, but it's still a really good read. So be sure, I'll give Justin a moment, see if he wants to reconnect, but join us next week. We're gonna get to some practical examples. I know I teased a little bit with live coding there. That's, as anyone who's familiar with how I run these kinds of sessions, I typically like live coding a lot. But next week's session is going to be a web architecture overview. So this was a little bit of the theory. Next week is going to be the application of that theory, how we take these concepts and apply them if you wanted to build a very large, rich web application. Oh, I think that might be Justin there. Oh, good timing.
Google unauthenticated me somehow. Just kicked me out. So what's next week, Alexis? I don't know if you already said.
I just did.
Cool. All right, I'm excited.
Web architecture. So.
Yeah. All right. We'll probably go through a little bit more what we just talked about in detail. Observer pattern, things like that.
Yep.
Cool. All right. Thanks, Alexis. And see you next week. Oh, follow us. Follow us on YouTube. All right. Bye.
Follow us on YouTube.